My name is James Luther alongside Kevin Ma, and we are Hexagon OCR. Our project was optical character recognition reader for manufacturing drawings. Let's get started. First, I want to talk a little bit about the motivation for the project. Something that Hexagon customers use their software for is to transition from a 2D drawing to a 3D design. And so, as you can see, a relatively small part has a lot of information that needs to be input, and right now this is done manually. Now this is not a very efficient process. It's prone to errors, and errors can lead to waste. So our goal was to use optical character recognition to begin to automate this process. And optical character recognition is defined as the identification of printed or written text using computer software. Now these programs already exist with relatively high accuracy for normal languages. One thing they are not capable of doing yet is to recognize geometric dimensioning and tolerancing symbols, known as GD&T symbols. These are used in engineering drawings to help create an accurate 2D representation of the component. Now our focus for this project was to recognize what is called a feature control frame, which is up here on the right. This is used to help define a surface of a specific part. Now our anticipated best outcome for this project was to create portable software with the ability to read GD&T callouts with greater than 90% accuracy. The effect on the market is great as it would improve speed and reduce waste, improve the efficiency of this process. Now, we did not satisfy the best anticipated outcome. As we got all alphanumeric characters and modifiers above 90%, we were only able to get 10 of the 14 GD&T symbols to that standard. For our key accomplishments, the first phase was choosing an OCR engine to start with as our baseline. And we chose Tesseract for this. Tesseract was developed by Google and HP, and it is an open source product that has an active community to help support, and it can be trained to recognize any Unicode character or symbol. This has a well-documented training process and was one of the main reasons why we chose it. For the process of training Tesseract, we had to use sample GDT image files and box files to do this. The target accuracy was above 90%. And all 14 GD&T characters needed to be trained, as well as all alphanumeric characters and modifiers. As you can see in this image here, a box file is basically just a character that is mapped to an XY value with height in a specific image. Now, for the third and fourth phase of our project, our goals were updated. Our original goal was to create a standalone program. As we moved forward and progressed, it was more useful to integrate this into a test harness that was similar to the structure that we were going to be working with Hexagon. And for the mobile solution, we decided to focus on training and integration that was not feasible in the time frame described. Now I'm going to pass it along to Kevin, who's going to talk about the test harness.
Thank you, James. Okay, so what I have here, this is the test harness that was developed for this project. And the test harness then acts as a similar environment to the PCD software, and the test harness that allows us to test our Tesseract training results without having to access or modify any of the source code for PCD. So the UI for this software is really simple and intuitive. We're clicking the browse button, and lets the user upload an image, and clicking the process URL button or process the image through Tesseract, and the result will be returned below. So at first, we were just running the images through Tesseract without any image processing, and we got really terrible accuracy. So we brainstormed and implemented some pre-processing measures. For example, we increased the DPI for all the images to 300 to increase resolution and quality. We also binarized the images from grayscale to black and white. And for some of the images, we also removed the outlines of the feature control frames. So after all these pre-processing measures were implemented, we saw a great increase in the accuracy of recognition. So over here we have an example of an image that was ran through the test harness. And this is what we consider to be a good quality image, as all of the characters, they are really clear and sharp after pre-processing. So for these types of images, Tesseract will have no problem recognizing most, if not all, of the characters correctly and accurately. However, sometimes the image will not be of such a good quality. as in this example. So even after pre-processing, as you can see, the characters, they're really blocky and they have low quality. And when the quality is low, TestRack will sometimes recognize one character from another. So for example, it might recognize the period here as a comma or the letter O for the number 0. However, in this specific instance, TestRack was not able to recognize all the characters correctly. Now this next example, it shows how a character can get misrecognized. So if you can see, the zeros in this columns, it got interpreted by TestRack as the GD&T symbols for roundness. And this is not what we want. So in order to resolve these types of recognition issues, we had to retrain TestRack many times. And during these retraining iterations, we put more of a focus on the problematic characters. So we fed TestRack more training data regarding these characters in the hope that TestRack will be able to differentiate between them better. So after a few months of training and testing, we were able to get 10 out of the 14 GD&T symbols to over 90% accuracy. We were also able to get all of the alphanumeric characters to over 90% accuracy. As for the remaining 4 GD&T symbols, they all currently have between 50 and 90% accuracy, and we passed on along our knowledge regarding this project to other developers and testers at Hexagon so that they may continue working on this even after we leave. And now I will pass it back to James with some closing thoughts.
We would just like to take a brief minute to thank Jonathan O'Hare for his endless support in this project. Without him, we would not be anywhere we are today. There were also 2 developers at Hexagon. John would like to pass along our thanks as they were instrumental in helping this project continue and progress. We'd also like to thank Dr. Sunak for the opportunity to work on this project. Thank you.